we are actually going to look at the gradient of a line. Let's go back to a linear relationship. We know that linear relationship in a Cartesian plane is actually a straight line. The general equation is y equals to mx plus c, and m is actually gradient of the line. Now, how do we actually define the gradient? The gradient of the line can be defined as the rise over the run over a certain interval. Now, what is the interval and how do we define rise over run? Let's have a look at a situation where we have a straight line with point A and point B. We know that the gradient of this line is the rise over run. And the run can be defined as the change in the x values when we move from A to B. And rise is the change in y values when we move from A to B. Okay, so run is the green line and rise is the yellow line. In this case, the run is 16 minus 2. That is the change in the values for the x direction, and rise is 18 minus 2, which is 16. Therefore, the gradient equals to 16 over 14, which is 8 over 7. So, we know that as we move from A to B, the y value increases as the x value increases. Therefore, this gradient is considered as the positive gradient. Have a look at a different situation. We are looking for the gradient of the line AB. Therefore, the run is 5 minus 8, which gives us 13. And the rise is 7 minus 18, which gives us minus 11. And the gradient therefore is minus 11 over 3. So what we can say that as we move from A to B, the y value actually decreases as the x value increases. This gradient is considered a negative gradient. This is in contrast to the previous example we looked at. This is actually a positive gradient and this is a negative gradient. So, in general, if we are looking for a slope between 2 points, A, x1, y1, and B, x2, y2, the gradient is rise over run. It's always y2 minus y1 divided by x2 minus x1, as long as x2 is not the same as x1. Now, let's look at the gradient of a line. Again, we use the same equation. Gradient m is rise over run. For a linear line, it actually does not matter which point we take as the first and which point we take as the second. Could be here, could be here, could be here. The rise over run for these 2 points should be the same as the rise over run for these 2 points. Therefore, for any linear line, we can just take any 2 points and the gradient can be calculated based on the coordinates of these 2 points. Let's have a look at 2 unique cases. One is a vertical line AB and the other is a horizontal line CD. For a vertical line, we know that there's a change in y. y2 minus y1 is 26 minus 4, which is 22. Whereas there's actually no change in x because it's 6 minus 6 vertical line. There's no horizontal movement at all. We're just moving up. So in this case, the run is actually 0, and therefore for a vertical line, there is no gradient. Whereas for a horizontal line CD, we know that there's always change in x, but there's no vertical movement, there's no change in y. So therefore, we know that the gradient is y2 minus y1, which is 14 minus 14, and x2 minus x1, which is 20 minus 9. and is 0 over 11, and that is equal to 0. So in this case, the rise is 0, and therefore for a horizontal line, the gradient is equal to 0. Let's have a look at a couple of examples. First, we need to find the gradient of the interval joining the 2 points 7, 4 and 10, 28. Using this formula, we actually can substitute the number directly in there. y2 is 28, y1 is 4, x2 is 10, x1 is 7. Therefore, we can find the gradient, which is 28 minus 4 over 10 minus 3, which equals 24 over 3 and equals to 8. Another example. Find the gradient of the interval joining the 2 points 2, 3 and 8, minus 7. Again, substituting those numbers into this equation, y2 is minus 7, y1 is 3. Minus 7 minus 3 gives us minus 10. x2 is 8. x1 is 2. X minus 2 gives us 6. So therefore, the gradient is minus 5 over 3. Using this formula, we can reverse engineer it and look for x or y coordinates. So let's look at this example where a line passes through the point 5, 7 and has a gradient 2/3. We need to find the x coordinate of the point on the line with y coordinate 13. We can actually draw out this line. We know one of the point is 5, 7. The other one is x, 13. We know the gradient, the rise over run, which is 13 minus 7 and x minus 5, and that equals to 2/3. Rewriting the equation here and manipulating the equation, we found that x is actually 14. Similar example, this time we need to find the y coordinate of the point on the line with x coordinate minus 1. Again, we can plot out or sketch the line. We know one point is 5, 7, the other point is minus 1, y. We know the rise and the run, and the gradient is 2 over 3. So therefore, 7 minus y over 5 minus 1 equals to 2/3. Again, by manipulating this equation, we found that y is actually 3. So I have shown you some examples on finding gradients and how to use gradient to find x or y coordinates. Let's have a quick summary. The gradient between 2 points x1, y1 and x2, y2 is given by gradient as a rise over run, which is y2 minus y1 over x2 minus x1, as long as x2 is not the same as x1. For any linear relationship, y equals to mx plus c, m is the gradient. And the gradient for this line is defined as the gradient of any 2 points on that line. A vertical line does not have any gradient, and the gradient of a horizontal line is 0.